Welcome to ShivaOps, evolving through innovation in AI, machine learning, agentic AI, DevOps, and modern engineering. Friends, welcome to ShivaOps. Great to have you here. Before I start, let me quickly introduce myself. My name is Shiva Naik. I am an Oracle developer with more than 20 years of experience in PLSQL, Oracle Forms, Oracle Reports, and enterprise in-house business applications, including MES-style manufacturing systems. Programming and problem solving are not only my profession, they are my passion. I strongly believe learning has no age limit, and I continuously explore new technologies through hands-on practice, local lab setup, installation, configuration, and working demos. Over the years, I have practiced across Oracle enterprise platforms, DevOps tools, cloud technologies, and AI-assisted development. Through ShivaOps, I want to showcase this practical learning journey and my transition from traditional Oracle development into AI, ML, agentic AI, DevOps, and modern engineering. So once again, welcome to ShivaOps. Let us start this journey together. In this today's video, I am going to explain my project called Smart Trip. Smart Trip is an AI-assisted airline booking simulator that demonstrates a realistic end-to-end travel booking journey. In simple terms, this application allows a user to search flights, select a fare, choose travelers, confirm the booking, make payment, and finally generate an itinerary. Now let's move to the agenda of the video. Before we move into the practical lab demo, let us quickly understand what we are going to cover in this video. First, I will explain the Smart Trip overview and main concept. Here we will understand how the application combines a guided booking flow with an AI-assisted chat experience. Second, we will look at the architecture and API provider simulation. This is an important part because Smart Trip is designed to behave like a real travel portal calling an external airline provider. Third, I will explain the role of AI, the development journey, and the message this project gives to developers. Here we will see why AI is useful, but why business logic, validation, and developer judgment are still very important. Finally, after this explanation video, the next video will be the practical lab demonstration. In that lab demo, I will show the actual Smart Trip application flow screen by screen. So let us start with the Smart Trip overview and main concept. Hello friends, great to have you here. Now that we know what Smart Trip is, let us understand the main concept behind it. Smart Trip is not only a booking screen and it is not only an AI chatbot. It combines two approaches together, a guided graphical user interface and an AI-assisted chat mode. In guided mode, the user follows a structured booking flow using forms, drop-downs, buttons, and screens. In AI chat mode, the user can simply describe the travel plan in natural language. The AI understands the request and extracts details like origin, destination, travel date, passenger count, class, airline preference, and currency. But the AI does not directly control the booking. The actual transaction is still controlled by application logic, validation rules, database configuration, and business workflow. This keeps the system safe, predictable, and suitable for an enterprise-style application. AI helps the user talk naturally. Business logic keeps the booking safe. Next, let us see how Smart Trip is designed like a real API-driven travel booking system. Now let us understand the architecture and API provider simulation of Smart Trip. Smart Trip is designed to feel like a real-world travel booking platform. In a real travel system, a booking portal usually does not keep all airline data inside its own application. It connects with external providers, airline systems, global distribution systems, or travel aggregators. For example, systems may connect with providers similar to Travelport, Amadeus, Sabre, direct airline APIs, or supplier platforms like Make My Trip style travel networks. Smart Trip follows the same design idea but in a local demo environment. Instead of using a paid external airline API, I created a separate local airline provider simulator. So there are two separate applications. One is the main Smart Trip application, which behaves like the travel booking portal. The second is the airline provider simulator, which behaves like an external airline supplier system. When the user searches for a flight, SmartTrip prepares a provider style request. This request contains details like origin, destination, travel date, passenger count, class, airline preference, and currency. Then SmartTrip sends this request to the local provider API. The provider receives the request, checks its own database, prepares available flight options, and sends the response back to SmartTrip. This creates a real request and response integration flow. SmartTrip is not simply reading everything from one internal table. It behaves like a client system calling a supplier system. This separation makes the architecture more realistic and flexible. Today, the provider is local. Tomorrow, the same design can be connected to a real external airline API by changing the provider integration layer, endpoint, authentication, request mapping, and response mapping. This design also helps in testing. Because the provider is local, I can simulate successful search, no flight found, booking success, payment success, itinerary generation, and error scenarios. So the demo remains stable but still feels like a real API integrated airline booking system. Next, let us understand the role of AI and the main message this project gives to developers. Now let us talk about the role of AI, the development journey, and the key learning from this project. Friends, this section is very important, so please listen carefully. Today, many IT professionals and developers have one common fear. Will AI take over programming jobs? This project is my practical attempt to answer that question. SmartTrip is not only an AI-assisted travel application, it is also a practical example of the real relationship between AI and developers. AI can generate code, speed up development, and help us learn new technologies much faster. But building a serious application still needs programming knowledge, business understanding, architecture thinking, testing, and human judgment. That is the core message of this project. SmartTrip was built with the help of ChatGPT using Python, Fast API, HTML, Jinja 2, JavaScript, CSS, MySQL, provider API simulation, booking flow, payment flow, itinerary generation, and audit logging. My main background is Oracle PLSQL, Oracle Forms, Oracle Reports, and enterprise ERP style applications. I was not originally a Python, Fast API, or web developer, but with AI assistance, I was able to understand and build a modern application step by step. At the same time, I learned one very important lesson. AI can generate code quickly, but if we do not understand the underlying technology properly, we may miss issues related to code structure, maintainability, standardization, and scalability. In some places, I may still find areas where the code structure can be improved because initially I focused more on the working flow and less on Python level best practices. I will highlight some of those areas during the lab demo. So friends, please do not consider those points as bugs in the application. They are part of the message I want to share about AI versus developer jobs. If we guide AI correctly, it can also refactor, stabilize, and improve the code structure. That is where developer knowledge becomes very important. So my message is simple. AI does not replace developers. AI empowers developers. Developers should upgrade their AI skills, learn how to use AI tools effectively, and combine AI speed with their own technical judgment. So friends, that is all for this project overview. Friends, before we move into demo series, I will quickly share how this project started, how the smart trip idea came into my mind, how it was designed, and how I use the power of AI to convert an idea into a working demo application. Recently, after completing my Oracle Cloud Infrastructure AI Foundations Associate and Oracle Cloud Infrastructure Data Science Professional certifications, I realized one important point. To build AI, ML, or agentic AI related applications, a good level of Python coding knowledge is very useful. Before starting this project, Python Fast API, JavaScript, Jinja 2, and modern web application development were still completely new practical areas for me. So instead of only going through Python tutorials line by line, I decided to try a more practical approach. I plan to directly build a smart trip application with the help of AI generated code while using my existing programming and enterprise application background to understand, control, and improve the flow. Of course, learning still requires referring to Python documentation, examples, and tutorials. But when we already have a working application in front of us, learning becomes faster, more practical, and more interesting than only reading theory from the beginning. At the same time, I wanted to prove one important point. AI generated code alone is not enough to build a working application. Developer role, judgment, review, testing, improvement, architecture thinking, module connection, workflow design, system reliability, and final delivery are still very important. So Smart Trip became my learning bridge from traditional Oracle development to modern AI assisted application development. The idea was simple. I wanted to build an airline booking simulator where a user can type a natural language request and the system can search flights, select fare, create booking, process payment, and generate itinerary. But I did not want Smart Trip to be only a chatbot. I wanted it to behave like a controlled business application where the LLM helps understand the user request, but the backend controls validation, database rules, provider API calls, booking logic, payment flow, and audit logging. So I started with my initial blueprint: database architecture, validation approach, business logic, and intended working flow. But the database design and table structure were initially prepared by me upfront and then improved further as new requirements, testing results, and enhancements came in. From there, my AI assisted development journey started. AI helped me generate the first version of Python code, fast API routes, HTML pages, Jinja 2 templates, SQL ideas, validation logic, and test cases. But that code was only the starting point. This journey continued for almost 8 weeks, mostly 2 to 3 hours daily outside my office working hours. I kept reviewing the code, refining my requirements, taking AI generated suggestions, fitting them into the application, testing the result, and repeating the same cycle for every new enhancement, new feature, new business logic, and new idea. During this journey, I also improved my Python understanding side by side. For the detailed behind the scenes story, please watch part 8 of this demo series, where I explain my complete AI versus developer journey. Now that you know what Smart Trip is and have seen the architecture overview, let me quickly explain the complete Smart Trip demo series roadmap. I have divided this Smart Trip demo into 8 focused parts instead of making one very long video. This makes the series easier to watch, easier to understand, and easier to follow step by step. Viewers can directly open the part they are interested in. For example, business users and decision makers may mainly want to watch the working AI assisted booking flow to understand the business value, while developers may want to focus more on setup, APIs, database flow, and technical implementation. So let us see what each part of the video series covers. Part 1. This video covers the introduction and architecture overview of Smart Trip. which we have already seen just now. Part 2 covers setup readiness, required services, application URLs, and a quick flight inventory data check. Part 3 shows a proper flight booking request using LLM chat mode, covering different successful booking test cases. Part 4 shows how SmartTrip handles validation scenarios and controls the booking flow. Part 5 covers missing or invalid data handling, including how the system prompts the user with proper selection options when required data is missing or not available in the flight inventory. Part 6 shows how SmartTrip handles outside booking requests and greeting messages. This is important to control unnecessary LLM API calls and to keep the flow aligned with airline provider rules and business agreements. Part 7 shows guided booking mode. This mode is kept separate from LLM chat mode so that AI related changes do not disturb the stable GUI based booking flow. Part 8 explains the technical developer journey, including code flow, API flow, LLM JSON handling, provider integration, audit logging, and the difference between AI generated code and the developer's actual role. Friends, that is all about the complete demo series roadmap. Thank you for watching part 1 of the Smart Trip demo series. In the next video, part 2 will cover setup readiness, required services, application URLs, and a quick flight inventory data check.